This video is going through all of our logarithm properties that we would have learned in 8.5. So we essentially had three properties. We had what was called the product property, which allows us to expand logarithms that have pieces that are being multiplied, expand using addition. We had our quotient property, which expanded a division into several subtraction pieces. And then we had our power property, which takes whatever we're taking the log of something to a power, that power comes out front and becomes the coefficient. So I'm going to go through three skills with you. We're going to work on expanding, which is the most common skill that you'll be asked, taking a single log and expanding it to multiple logs. Then we're going to condense, going in the opposite order, taking multiple logs and condensing it to a single logarithm. And then we're going to finish with the change of base formula, which we learned at the end of the section. So we're going to start with expanding, and you can do these in one step. You can do them in several steps. It's really your comfort level. I'll try to go kind of slowly as we go through, but if you can go faster, that's fine. So when I expand this, everything here is being multiplied. So I'm going to write it as the log base 3 of 4, and then plus the log base 3 of x, and then plus again the log base 3 of y squared. So I'm first expanding all of the pieces that are being multiplied into three addition pieces. And then there is one piece left, and a lot of times the piece that people forget to do, it's taking that power and bringing it out front. So we have log base 3 of 4 plus log base 3 of x plus 2 log base 3 of y. When you finish these problems, a couple things to check. Make sure that your log base has not changed. So this problem started out as log base 3. It should be base 3 in every single log when you expand it. The other thing is make sure there's nothing that you could evaluate. For example, log base 3 of 4 is not something you could do in your head, but if it would have been log base 3 of 3, that is something that you should know how to do. So you want to look at the numeric ones, and then finally make sure that you have brought all the powers in front. Sometimes, especially if maybe it's written as a radical or written in a different form, it's easy to forget that step. The next one, I'm going to break it up with subtraction first. So I'm going to have the log of 2x minus the log of the cube root of z. Then I'm going to break up the first two a little bit more because these are being multiplied. So I'm going to have the log of 2, it's just common log of 2, plus the log of x. And then finally, I need to think of this as a power. This cube root of z is actually z to the 1/3 power. So I'm going to bring my 1/3 out front. So I have 1/3 log of z. And again, checking to make sure that you kept the same log. These are all base 10 common log, and making sure that all of your powers have been brought out front. Going the other direction, condensing means you're starting out with multiple logs, and in the end you're going to write it with a single log. So this time you actually want to put the powers back first. So I'm going to take this and make it the power of x, and I'm going to take this power and make it the power of z. So I'm going to have log base 4 of x cubed plus log base 4 of y minus log base 4 of z to the half, or you could write it as the square root of z if you're more comfortable with that. And then I'm going to take these two and multiply them since they're currently being added. So you're going to have log base 4 of x cubed y minus log base 4 of z to the 1/2. And then finally, I want to write it as a single logarithm with division because it's being subtracted. So your final answer is log base 4 of x cubed y over z to the half, or the square root of z. When you're done with your condensing, you should only have log written once. You have one log, and then you just need to figure out where everything else belongs. Anything that follows the subtraction sign belongs in the denominator. Anything that has a coefficient needs to have that as the power. And again, your logarithm base doesn't change. It stayed log base 4 the entire time. This one, same thing. I'm going to put the powers back first. So I have log base 3 of 4 squared, which is 16, plus log base 3 of x to the 1/3, or you could write it as the cube root, plus log base 3 of y cubed. Now when I put it together, everything's being multiplied, which means when I write my single log, it's going to be written as a product. So I have log base 3, and it's going to be of 16, x to the half, y to the 3rd. Again, I should only have log written once. I should have the same base as what I started with all along, and everything should be put back into a single log. The last thing we did in this section was a formula that helped us evaluate logs that we couldn't necessarily do on our calculator, not common logs, not natural logs, and we couldn't also do in our head. They weren't logs that you could figure out very easily without having to do some more work. So what we have log base 9 of 24, not something that we can figure out in your head. We are going to get a decimal answer. Our change of base formula says that we can change it to either a common log base or a natural log with base e and get an answer. And the way that it works is you're going to take the either common or natural log. I usually use natural log, of this larger number, the 24, divided by the natural log of your base number, 9. You're going to need a calculator to do this, and you are just going to type in exactly what you see. So you're going to have the natural log of 24, close out your parentheses, divided by the natural log of 9. You do not have to close the parentheses there. And you should expect a decimal, especially when they're telling you that you'll need a calculator or that you do need to use the change of base formula. Your expectation should be is not a whole number. So this one, we're going to take the natural log of 5 divided by the natural log of 2/3. We're going to have to be a little more careful with parentheses on this when I enter it. So it's going to be natural log of 5, close your parentheses, divided by natural log of 2/3. That should be contained in its own parentheses. Get negative 3.969. And then same thing as the last one, just to show you that it works either way. If you don't want to use common log, you could do, or you don't want to use natural log, you could use common log. So here is common log of 57 over common log of 2. You're going to get the same answer as if you chose to do it as natural logs. So log of 57 divided by log of 2. Again, make sure you're closing your parentheses. Get 5.833. And that would be the same answer if you chose to use natural log instead. The only thing you can't do is you can't use a common log on top and a natural log on the bottom. If you decide you're going to do it all with natural logs, then you need to be consistent. Same thing if you decide to do it with common logs. This helps us with a lot of our solving. So we continue to use this formula in the next section when we start solving exponential and logarithmic. And it also helps us with logarithms where we're just having trouble evaluating mentally without having to go to a calculator.